This is our 5th video dedicated to the Gilbreath principle and finding surprisal values for Gilbreath performances. Today we will be looking at the most famous organization of a deck of cards. It's called the Si Stebbins arrangement of the cards. So let's cover some basics over here in our Desmos activity as far as definitions. Given a standard deck of 52 cards, we will analyze packets of size 4V that consist of V clubs, V hearts, V spades, and V diamonds, where the V cards for each suit have the same number of card values as those for the other 3 suits. Examples. 1. If we use the entire deck of 52 cards, V would be equal to 13, and we would be working with a Si Stebbins or similar packet structure. 2. If we choose to use only the aces, the 2s, and the 3s in each of the 4 suits, then V would be equal to 3, which means the packet size would be 4 times V, which is equal to 12. 3. If we use the card values 2, 4, 6, 8, and 10 in each of the 4 suits, then V would be equal to 5, which means the packet size would be 4 times V, which is equal to 20. Vocabulary. We will usurp the name Si Stebbins to refer to any packet in which the cards alternate in color, cycle through the 4 suits in some consistent order, and cycle through the V distinct card values, also in some consistent order. We will analyze 3 packets. The first structure is an SS packet, named after Si Stebbins, in which the cards alternate in color, cycle through the 4 suits, and cycle through the V distinct card values. Consequently, SS packets have 3 interwoven cycle structures, whose cycle lengths are 2, 4, and V. For instance, the following is a SS structure, for example 2, where the distinct card values are ace, 2, and 3. Observe that the packet satisfies the 3 Si Stebbins properties. First, the cards alternate in color. Second, the cards cycle through the suits in some consistent order. And 3, the cards cycle through the values in some consistent order. Please note that we can form many different packets using the same cards that satisfy the Si Stebbins properties. In other words, there are many SS packets for a given set of permissible cards. To construct another SS packet using the above cards, we could consistently reorder the card values and/or consistently reorder the suits, as long as the cards still alternate in color. Furthermore, all such packets would be structurally equivalent to each other relative to the Si Stebbins properties. Special assignment. Before moving forward, please explore why the permissible values of V are odd numbers between 3 and 13 inclusive. The second structure we will look at is an SS packet that has been Gilbreath shuffled. We will refer to these packets as GSS packets. To facilitate graphing in Desmos, the variable X will be used in place of V. In other words, the functional variable X that we will use represents the number of distinct card values we have chosen, subject to the constraint that X must be an odd number between 3 and 13. Therefore, when interpreting the various graphs, we need to mentally multiply the value of each x-coordinate by 4 to obtain the actual size of the packet of cards being represented. Although each of the following functions only make sense for discrete values of x, namely odd integers between 3 and 13, Desmos uses a generalized factorial function, the gamma function, to draw a continuous graph that connects the corresponding discrete points in the plane. So let's go ahead and look at our Surprisal functions. For Si Stebbins, arrangements of the cards, as well as Gilbreath shuffled Si Stebbins arrangements of a packet of cards. So just to review, a Si Stebbins organization involves the interweaving of cyclic structures of cycle lengths 2, 4, and in the case of the entire deck, it would be 13 for the card values, where the packet structure is cyclic relative to color, cyclic relative to suit, and cyclic relative to card value. Now, the total number of SS packets is 8 times x factorial, where x is an odd number between 3 and 13. And remember, x represents the number of distinct card values in a packet of 4x cards consisting of x clubs, x hearts, x spades, and x diamonds. And I do want to point out that the expression here that gives you the total number of SS packets for x between 3 and 13 is simply based on the fundamental counting principle, also called the multiplication principle. So the mathematical machinery needed to derive this is not sophisticated. Okay, so this is within the reach of most any viewer of this video. Moreover, the total number of permutations of these 4x cards is the quantity 4x factorial. Given the above 4x cards, therefore, the probability that a random mixing of these cards would yield an SS packet structure is the following. It's the total number of SS packets divided by the total number of permutations of those cards. That gives the probability. Consequently, the surprisal of such a packet occurring by chance alone is log base 2 of 1 divided by the probability, which is equal to log base 2 of this expression here, where once again x is an odd number between 3 and 13. So this gives the derivation for the first surprisal function in our Desmos activity. The second surprisal function is simply obtained by deriving the total number of packets having a post-Gilbreath-like structure divided by the total number of permutations of those cards. And of course, because the surprisal is log base 2 of 1 over the probability, it flips the fraction inside, as was the case for our original surprisal function for SS packets. Okay, so both of the expressions needed to build these surprisal functions can be derived from the fundamental counting principle. Okay, so let's go ahead, and I have a deck that is actually set up as a Si Stebbins arrangement of the cards. Okay, now I do want to point out that elsewhere on my channel, I actually have videos that show you how to set up a Si Stebbins arrangement of the entire deck of cards. So if you just look up Si Stebbins, the name is up here at the top, S-I and then Stebbins, and then type next to it hidden structures, it should bring up one of my several videos dealing with the Si Stebbins deck organization. Well, how this works is we have these 3 interwoven cycles of length 2, 4, and 13. Okay, so let's just take a look. So, of course, the first cyclic structure will be the alternation of colors. So we have black, red, black, red, black, red throughout. Okay, and then we have it cycling through the suits in chaste order. Clubs, hearts, spades, diamonds, clubs, hearts, spades, diamonds, and so forth, all the way through. And then we have it cycling through in card value as well. Okay, and the arrangement is as follows. It's ace, 4, 7, 10, king, 3, 6, 9, queen, 2, 5, 8, jack. And then it repeats that again, ace, 4, 7. So what's happening here is each card value determines the next one by adding 3 to the value. And so you can see that we begin with an ace, so you can think of that as having value 1, and then we add 3 to 1, we get a 4. Adding 3 to 4, we get a 7. 7 plus 3 is 10, and so forth. So you're just adding 3 to the card values to cycle all the way through, with the proviso that there are 13 card values in your cycle, ace through king. Okay, so this essentially has that special property that we saw in the first 3 videos dedicated to the Gilbreath principle and Surprisal values, where we had packets with cycle length 2, and then packets with cycle length 4, and then packets with cycle length 13. Well, this deck structure has all 3 of those at once. At once. Okay, that's the important thing. So as you might imagine, to randomize a deck of cards and find that it has these 3 properties simultaneously is extremely unlikely. In fact, we can see that here in our table to the left, okay? So here we're working with a whole deck of 13 card values. The chance that you would get this deck here by chance alone is 190 bits, okay? So if you want to think about our coin tossing example, that's like tossing 190 coins high up into the air and then calling heads for all of them. They're all going to land heads up, and you watch those coins hit the ground and bounce around and eventually settle down, and every one of those 190 coins are heads up, and you predicted it ahead of time. Okay, so that's how unlikely it is, or in other words, how surprising it would be for such a deck structure as we have here to occur by chance alone. Okay, now, of course, that is outrageously unlikely, but what we are interested in is Gilbreath shuffling this packet. That's the key. Okay, so we have this special structure with 3 interwoven cycles, and now we're going to Gilbreath shuffle this and look at the properties that result. Okay, now you would think that after shuffling this, those special properties that we've given this packet because of its arrangement, that they would be destroyed or in some way disrupted where they don't hold anymore. Well, that's not quite true, as we'll see, okay? So what we're going to do now is we're going to Gilbreath shuffle this, okay? And if you've been watching these videos dealing with Surprisal values and Gilbreath performances, you know how to do a Gilbreath shuffle. So for example, we can just reverse count as many cards as this. In fact, you can have the spectator do this. They can deal out as many cards as they would like, okay? Now, it's not a bad idea to deal out about half, just so you can riffle shuffle them fairly well. So, but they can deal out any number that they like. If you remember, we can just do a traditional riffle shuffle, or we can do a rosette shuffle where you spin them and then bring them together, okay? Well, since we have the whole deck here, it would make sense to just go ahead and do a classic, just do a riffle shuffle. So this is where you just let the cards fall how they may, okay? Like that. And now what we do is we look at the structure of this packet. Well, the Gilbreath principle says something special about each of those cycles of different lengths, okay? So of cycle length 2, what it says is the cards taken as pairs from the top will consist of one of each color, okay? So we get red, black, black, red, and so forth, okay? So each pair taken from the top, as we go through the entire deck, we are guaranteed to get one of each color in some order. We don't know the order. The order cannot be known ahead of time. It will depend on how these were interlaced together and how many cards were dealt to the table, right? That will determine this. Okay, so that is one property that we'll get. And then the second property involves cycles of length 4. Well, because we had cycles of length 4 where we had repeating suits, that means that as you take these off in groups of 4, there will be one of each suit guaranteed. So you get heart, club, spade, diamond. Here we get spade, diamond, club, heart, okay? And so as you go through, you'll get one of each of the 4 suits within each set of 4 cards, okay? And that will always happen because of the Gilbreath principle, okay? So club, heart, spade, diamond there. So we're getting one of each. Spade, heart, club, diamond there, and so forth, okay? So it's a perfect set of one of each in each group of 4 cards taken from the top, okay? Or the bottom for that matter. Okay, so there we go. And then because we had a cycle of length 13, what will also happen is if we take groups of 13 cards at a time, so 13 cards, so that's 13 I believe, and we'll check it here. Maybe it's too many. Let's see, let's check there. So 13 cards, we should have one of each. That's the first set of 13 from the top of the deck. So we have an ace, a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, and king. Okay, so that's the first set of 13 cards. So let's do 3, 6, 9, 12, 13 again. So this should also consist of one of each of the 13 card values. And as you can quickly check, it is the case. There's an ace, a 2, a 3, all the way through to a king. And then if we take the next set of 13 cards, 6, 9, 12, 13, that should also consist of one of each of the 13 card values. And as we can check, that is the case. Ace, 2, oh, that's the other ace from before. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, and here is the final one. And maybe I'll just hold it up so we can see it and not get confused with the cards all over the table there. Okay, so we have an ace, a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10, jack, queen, king. Okay. So let's take a look at the surprisal value of this Gilbreath performance. Now you have to remember that the spectator, when we went to deal the cards They are the ones that decided how many cards to reverse count. This was their decision. They could have dealt none of them, one of them, or all of them if they wanted. Okay, so they dealt some number, and then they are allowed to just riffle shuffle these together however they would like. However, the cards happen to interlace with one another by way of a riffle shuffle, or come to think of it, let me just put out a few more so we can see this. Or we could have had them, if you wanted, we could have had them, instead of doing a traditional riffle shuffle, they could have done a rosette shuffle. Okay, you remember that? Where you put out the two piles and then you spin them like this and then you just bring them together like that. So we could have done that shuffle instead if we chose to. So let's go ahead and look at the Surprisal value for this Gilbreath performance involving the Si Stebbins arrangement of a deck of cards. Well, we used all 13 card values. So the Surprisal is 56 bits. 56 bits of Surprisal are associated with successfully performing this Gilbreath routine. How do we interpret those 56 bits of Surprisal again? Well, one interpretation is it's the same level of surprise one would experience in tossing 56 fair coins high up into the air, calling heads for all of them, and then having all 56 coins land heads up. And you predicted it ahead of time. So that's the same level of surprise one would experience in watching a successful completion of this performance here. Okay? Another interpretation that we gave, which was fun, is in terms of true-false questions. So this would be the level of surprise associated with what you just saw here is the same level of surprise one would experience in taking a true-false quiz that has 56 questions and you have no idea what the answers are, so you just completely guess on each and every one of those 56 true-false questions, but nonetheless you score 100% on that crazy quiz. So the level of surprise associated with doing that is the same as the level of surprise of this Gilbreath routine here. We also gave the other interpretation that the Surprisal associated with being struck by lightning is about 20 bits. So here we're looking at almost 60 bits. So this would be similar to the level of surprise associated with an individual being struck by lightning 3 times throughout their life. Talk about bad luck. Talk about an unlikely set of events. Well, that's the same level of surprise a spectator would experience in seeing this successfully performed. So thank you for watching, and I hope you've gained much from these Desmos activities involving the computation of Surprisal values for Gilbreath performances. And I hope that you'll watch other videos in this series and take a look at the many other series on the Hidden Structures channel. So thank you again.